Hi everybody. In this lecture I'm going to talk about more configuration options in Oracle Golden Gate. By the end of this lecture, you should be able to manage Oracle Golden Gate report files, implement batch SQL processing, use compression on the outgoing blocks of records, and understand and use event marker system. We have already seen the report files in a previous lecture. In this lecture, I will talk in more details about the report files and how to do some configurations on them. As I discussed before, report files contain information about the activities performed by the Golden Gate and any warning or errors issued by the processes. That's why it is an important monitoring tool for a Golden Gate administrator. By default, report files are saved in the subdirectory dir rpt under the Golden Gate home directory. Oracle Golden Gate keeps saving up to 10 report files per process. The file name takes the format of the process name followed by a sequence number and the extension RPT. The sequence numbers start from 0 up to 9. Each extract or replicate process generates a new report every time it starts up. If you want to review a process report, you can use the View Report command followed by the process name. The command will display to you the most recent generated report or the current report. This is the report that has been generated by the process since the last time it started up. If you want to display an older report, you can pass to the command the file name of the required report. As I said, the old report file names take the format process name followed by a sequence number. You have two examples in the slide. The first one will display the most recent report of the process EHR. The second example will display the second most recent report. I will talk now about some of the configurations that you can make in the parameter file to control the way the reports is generated. The first parameter is a report parameter. You use this parameter to specify the interval at which extract or replicate generates the runtime statistics in the process report. The statistics are added to the existing active report. You can define the interval to be at a specific time or to be at a specific day and time. Report count parameter is used to report count of the transaction records that the extract and the replicate has processed since startup. Each transaction record is a database operation captured by the extract or read by a replicate process. You use this parameter to schedule the record counts at regular intervals or after a specific number of records. If the extract process keeps operating for a long time, you would be interested in controlling the size of the active report file. With the report rollover parameter, you force report files to age on a regular schedule instead of when a process starts. You can specify a time of day, a day of the week, or both. Specifying just a time of a day without a day of the week generates a report at the specific time every day. If you want to manually generate a process report based on your request, use the command send with the report option. When this command is executed, the process updates the report with the most recent statistics. In this slide, we've got the trail file read by the replicate process and as usual the trail file has commands in it. When operating in the normal mode, the Oracle Golden Gate replicate process applies one statement at a time. You can configure the replicate process to run in batch mode. In this mode, the actions are grouped by table, DML operation, and columns. When the batch SQL mode is enabled, the process saves similar SQL statements into arrays in the memory. It groups the statements by table, DML operation, and columns. In the diagram shown in the slide, the red boxes are updated statements to the imp table. Those commands are grouped together because they are of the same commands to the same table. The orange commands are separated from the blue commands, although they all apply to the reports table, because the orange commands are delete statements and the blue commands are update statements. Having the statements grouped this way makes the replicate apply them more efficiently in normal cases. Batch SQL is a parameter that is applicable to a replicate process. As I said earlier, it organizes the similar SQL statements into arrays called batches. This arrangement will take place in the memory of the target system. This should lead to increasing the performance of replicate process. The difference in performance will significantly be observed with small rows. According to Oracle Golden Gate documentation, at 100 bytes of data per row change, Batch SQL has been known to improve the performance of replicate by up to 300%. But actual performance benefits may vary depending on the mix of operations. The duplicate process may automatically include a statement in a batch to preserve the referential integrity. This slide is showing the syntax of Batch SQL parameter. Batch SQL has options to control mainly the memory used to save the batches. I will show you in the next slide the meaning of those options. No batch error mode and batch error mode are mutually exclusive. You can use only one of them at a time. No batch error mode causes the replicate to switch to normal mode when it faces an error. This is the default behavior. With the other parameter, which is batch error mode, when the replicate faces an error, it tries to resolve the error if it is caused by a conflict. It converts the inserts that fail on duplicate record errors to updates, and it ignores missing record errors for deletes. When using batch error mode, use the handle collisions parameter to prevent replicate from appending. The 5 options that come after that in the list control the memory used by the replicate when it works in Batch SQL mode. The batches are saved in a memory area called the memory queue. You can control the number of batches in one memory queue, maximum number of bytes per one queue, maximum number of operations in one batch, maximum number of row operations in all batches in one queue, and maximum batch operations before commit. As a benchmark for setting the values of those options, assume that a batch of 1000 SQL statements at 500 bytes each would require 10 megabytes of memory. You can configure the extract to compress the data before it sends it to the remote host. To do that, use the compress option of the RMT host parameter. When the outgoing blocks of records are compressed, the bandwidth of the network required for packets transfer will be reduced. This option is valid for online or batch extract processes. use the compress threshold to set the minimum block size on which the compression should be performed. By default, it is set to 1000 bytes. Golden Gate has a system called Event Marker System. It is also known as the Event Marker Infrastructure, or EMI. With this system, you basically tell the Golden Gate whenever you find a record in the transaction log or in the trail file that satisfies a specific condition, perform a given action. The record that triggers the Golden Gate to perform the action is called event record. Let me explain this concept in this diagram. A DML is issued against a given table or event table. Event table is just a normal table in the database that is solely dedicated to the event marker system. When the extract processes that record in the transaction log file, it can perform a set of defined actions. This may include generating a process report, writing some information in the log files, issuing a checkpoint, or even executing an operating system shell script. I will show you later a list of the actions that can be defined in this system. The same applies on the replicate process. Exactly in a similar way, you can define a role of event records that will trigger one or more actions. As I said in the previous slide, Event Marker System enables the Oracle Golden Gate extract or replicate processes to take a defined action based on an event record in the transaction log or trail file. The event record that triggers the action could be one of the following: a record in a data table that satisfies a specific filter condition. The other way of defining an event record is when a record is inserted into a dedicated event table. Event table is a table that you create in the source database solely to be used for storing the event records. As I said earlier, actions can be performed by extract or replicate processes. The whole system is implemented by simply the event actions option of the table or map parameters. So far, you know that we use the table parameter for extract process and the map parameter for the replicate process. And yes, both of them have the event actions option that you use to configure the event marker system. However, there is actually a table parameter for the replicate process, but that parameter is mainly used only for configuring the events. I will show you an example of using this parameter later. This is a list of the actions that you can configure in the system. You can configure one or more of the following actions: stop a process, ignore or discard the current record, log an informational or warning message to the report file, Oracle Golden Gate error log file, and system event log file, generate a report, roll over the trail file, activate tracing, write a checkpoint before or after writing the record to the trail, and even run an external shell command in the OS level. This is the syntax of the event actions option. Each of these options is corresponding to one of the action list in the previous slide. Although it looks like a long syntax, it is actually simple. I will show you in the next slide examples of using this option. The first example is instructing the replicate process that whenever you encounter a record where command number equals to 100, write into the log file. It also instructs to discard that record. Discard means ignore that record and do not apply it in the target database. In some cases, you may actually do that because you inserted that row only to instruct the replicate to write into the log file. you don't actually care about storing the record in the target database. This is an example of a record in a data file that satisfies a specific filter condition. The second example is an example of a record inserted into an event table. In this example, the extract will roll over the current trail file whenever a record is inserted into my events table. You can combine two or more actions in a single event actions clause. The actions will be executed in an order according to which one takes precedence over the other. In the table in the slide, the actions in the before column are performed before the record is written to the trail or applied to the target database, whereas the actions that are listed in the after column are executed after the record is processed. As illustrated earlier, if you want to perform the actions and not to process the record at all, specify the ignore or discard action in addition to the other actions. Also observe that we have two modifiers for checkpoint action. One is checkpoint before and the other is checkpoint after. I will list here some cases of event marker system. You may want to perform a regular job on the systems that require stopping the replicate process. Instead of stopping the process from OS level, you can use the event marker to send the request from the database in a record, and the process will automatically stop when it receives that record. Another example of using the event marker system is to monitor the data anomalies and stop the process if it happens. For example, if the process finds that the withdrawal amount is more than the balance, it will automatically stop. The code example in the slide is showing how to use the system to trace a specific transaction. If an order of number 1 is inserted into the table, the process will record the tracing the transaction in the given trace file. In another scenario, you may need to run a batch in the target database that you don't want to replicate to the target systems. The code example in the slide is showing you how to do that, assuming that the whole batch job is done in a single transaction. The extract process will simply ignore that transaction. In this lecture, you should have learned how to manage Oracle Golden Gate report files, implement batch SQL processing, use compression on the outgoing blocks of records, and understand and use event marker system. The next lecture is a practice lecture where you will implement some of those concepts. Thanks for staying with me. See you in the next lecture.